Alright, let's take a look here. First one, it's kind of funny, the variable invasion on the first one is very minimal. Just put an X in both, so it almost doesn't even matter. This guy needs a 7, and this guy needs a 2. So they both end up with 14x on the bottom, and here we get 21 plus 8. 29. Who's going to help me? Okay. This is a good example of a problem that everybody, not everybody, but a lot of people try to do this, and I'm like, oh my God, don't do that to me. What comes out above? X. So who's missing what? First guy missing an X, and now they both have this bottom. Okay, cool. So here I get X minus 2. Done! Nothing's canceling, right? Look at bore you and say, why can't I kill you? You already know it's subtraction, it can't be killed by division, blah, blah. This is the one we talked about specifically because it happens often enough. You're not allowed to add something to the top and bottom. That doesn't keep the fraction the same. So, does this bottom have an M in it? No. Nope. And I know there's always somebody like, everybody's flipping crazy in this place. No, it doesn't have an M in it. Same way that 5 don't have no 4 in it, even though 5 is 4 plus 1, it doesn't have a 4 in it. It's not a factor of 5. So he doesn't have an M, he didn't have an M plus 1, so obviously he needs an M, and he needs an M plus 1. They need each other. They need each other. So then I get, now here's these last two, what do you have to be careful about? Yeah, so how should I rewrite this? So now I won't forget the negative 4 is what's got to go through. Give up, car. So on the bottom I get this. On the top I get 3m minus 4m minus 4. So I get negative m minus 4 over m times m plus 1. Nothing's going to cancel. Everything's factored. I've already seen nothing's going to cancel. So everybody all right with that? Real quick, side note. We haven't done this in a while. This is what the problem started off like, right? And then I got that answer, right? How can I check that? Yep. Redo it. No. I can let m be something. Give me a number m. 2. All right, I like it. That's going to come out interesting. So if m is 2, the problem started off like this. 3 over 3 minus 4 over 2. That's really nice, right? That's 1 minus 2, which is negative 1. So if that is the answer, it better have the same value for whatever value of m I pick, because they're supposed to be equal to each other. So if m is 2, what do I get on top? I get negative 2 minus 4 over 2 times 2 plus 1. Negative 6 over 2 times 3. Negative 6 divided by 6 is? Kick-ass! That's extra. If you really don't understand that, it's not the greatest, but that's extra shit. It's not as important. Okay, maybe. Alright, I like it. So here, obviously, the first thing I have to do is factor. I think we pointed this out before. These are kind of like the most evil numbers. They're so small, but they're so evil because negative 6 and 1 make some kind of 5, and they also multiply by some kind of 6. But so do 2 and 3. They make some kind of 5, and they multiply by 6. Oh, shit. But here, everything's flipping positive, so it's got to be 2 and 3. This one, only one way to factor 2. Thank God 2 and 1 make 3 also. When you add them, I like it. So now you can see who's missing what. He's missing a x plus 1. And what I should have done in the first place was this, right? And he's missing a x plus 3. So let's see. So now they both have x plus 1, x plus 2, x plus 3. And this guy becomes what? 5x plus 5. Minus 2x. Minus 6. So then I get 3x minus 1. And I can see really quickly it's not going to go anywhere. Everything's factored already. Nothing cancels, so I'm done. Remember, don't multiply that bottom out. That's just busy work. Don't do that. Assuming that's why everything's busy work. Yes?
So once we factor everything out, we just put it as like one long equation.
Yeah, once you get the bottoms the same, you know when we add like denominator fractions, the bottoms stay the same. Right? 1/2 plus 1/2 is not 2/4. It's 2 halves. Yeah, cool. I like it. Okay. That skill by itself is the same skill that helps us solve equations. These are not equations yet. So let's review that. Is everybody cool with those? Yes, okay. What if I add this here? What do you got, John? Yeah, let's do something else. Oh, this is really going to do. Well, okay, I'll do this. Not too bad. I don't know if you guys remember when we got to the section where we were reducing. Actually, it's just earlier, a few days ago. We were multiplying things, and I said, if there's a cube in that problem somewhere, do it first. Because somebody's going to look at this and start to try to factor this. It ain't going to It's not going to go anywhere. Because that, more than likely, is the big dude from this guy, which you can never factor. So don't start with your trinomials if there is a cube somewhere in there, because this might be the big dude from him. You can't factor those. You're going a little insane. More insane than I've already driven you. So I can't factor him. How do I factor this guy?
X minus 2.
Good. 1x minus 1, 2.
X squared.
The other 2 x's, the other 2 2's. Plus 2x. Hey. Right? So, what's that second dude missing? X minus 2. Oh, I didn't make an equation out of this. Jeff. Here you go, ready? Equals. Sorry. Let's make this not too crazy. Yeah, okay. Sorry, so add that in. Forgot I wanted to go to the next section. So what's he missing? He's also missing the x minus 2. Is that cool? Let's make this on the fly here. Since this is an equation, I can do more than I could if it wasn't. Since it's an equation, I'm allowed to multiply both sides by something. I can multiply by both sides by any damn thing I want to, except 0. So obviously here I'm going to multiply by this bottom. I forgot to put that there. It's my fault. Right? I multiplied top by this, I better multiply the bottom by this. So now I can multiply the whole damn thing by this. And again, why am I allowed to do that? Because there's an equal sign that makes that come out balanced. No equal sign? As much as you want to kill them, you can't kill the fractions here. So if I multiply everything by, how many colors are you going to use, huh? X minus 2, x squared plus 2x. Bam, bam. X minus 2, x squared plus 2x plus 4. Cancel, cancel. So what am I left with here? 4x. Yeah, he's gone already. 4x minus 2x plus 4, I like it. 5x minus 10, and that's easy. Don't even hesitate to say that, yes.
So once we get the bottom the same, we can just cancel all that. And just throw it out?
If it's in an equation, because you can multiply both sides by that bottom.
Gotcha. Okay.
That's why the first step is make them all the same, because then they can all just disappear. And now, easy peasy. So I get 2x plus 4, 5x minus 10. So I get 3x, careful, add the 10. The negative 10 can't just migrate over there. Right? Let's not, might not be the best word to use right now. Then, sorry, I have all these Trump jokes related to math, but no. X equals 14/3. Now, all right, so pretty cool with that? You guys all right? You guys all right? So it's not that far away from what we were doing here. It's got a couple more steps because it's an equation. I need to get answers then. Why is that answer okay on the surface of it? What's the only thing that makes the bottom 0? 2. This one actually, you can't even factor, you just got, don't worry about this guy. So is x 2? No. Does that mean that works? I don't know, but at least I know it doesn't make it undefined. You don't have to throw it out. I like it. I like it. Yes?
Earlier, where did you get the x minus 2? That's part why I got lost.
Oh, factoring this guy.
Okay.
Little dude, big dude. Yeah. So then I can see what the other guys were missing. Kick ass. Kick ass. Let's do another one, and then I've got a practice worksheet for you guys. By the way, if you came in after I wrote this down, quiz Tuesday, 6-7 through 7-4.
Can you hear you?
Yeah, that's the right reaction. Let's see what you got, Chad. Now, this has come up before, but these kind of problems have hints and like major hints. This one I don't need a hint. You should be able to factor this anyway, but do you see how that's going to factor like those? Almost has to happen always for us. Almost always has that. I don't know, grammar. Just keep thinking somebody's sneaking up.
Hey, you got the right mentality. That's how you have to live in the hood, Chad.
Okay. This is part of campus, the hood. What happens?
It's the hood now.
Trust me, man. Look at some instrument. Let me see. All right, so that's the only part that gets back there. So we can cool with that. So what's this guy missing? X plus 2. He's missing. That's 9. Alright, see, so you start to get a rhythm for these things. So now I can multiply everything by what? By the bottom. I love it. So if I just multiply everything by x minus 9, x plus 2, it's going to distribute. That's going to distribute here, here, and I got to do the other side.
You can practically do that every time, right?
Yes. If you get an equation and you get all the bottoms the same, you can really just make them all go away. Sounds like a mafia kind of.
Right, but whatever you do to the bottom, you have to do to the top, right?
Okay, sure. So this is an example of what you just said.
Yeah.
This is not.
Okay.
This one I'm multiplying both sides of the equation by this. So it cancels here, it cancels here, and it cancels here. I'm not doing something to both sides of a fraction. What am I doing with this? I'm doing something to both sides of the equation.
Okay, got you. Damn, it's too many rules. Alright.
And why is it I'm doing this? To kill the bottoms. So if you still have a bottom after doing this, something's wrong. Yes?
Alright, just one more question.
Yeah.
So like you just said, we put the x2 for the 3, right? And that's like after it? Or I was just gonna say-
Wait, so the x2 for the 3.
But we do the bottoms and top, right?
Yeah, so this fraction right there, what was it missing that the other guys had in x plus 2?
Alright.
So the only way I can make an x plus 2 show up here is to also put it on the top. The only way I can multiply this side by this is to also multiply this side by this. I love that analogy. You always have to do the same thing to both sides. Equation, both sides, fraction, top and bottom side. You got to do the same thing to both sides. I like it. So what's left alive?
6x
6x
plus 3.
Give that, all right. Good. The most common mistake is to kind of forget to distribute that through. Yeah. And then let's see, 9x subtract 4x is 5x, subtract 6 is negative 42, divide by 5, you get that business there. That's yummy.
Ew.
What x's would I have to throw out?
Negative 9x.
9,
Oh, 9.
negative 2. And I didn't get either one of those, so that's a valid answer. At least it doesn't make it undefined. You want to check that? No, I don't. Okay. You still could, but man.
So we're going to start to get those like gross, irrational numbers and stuff like that.
Dude, yes. I'm going to continue to.
Alright.
One last quick one, and then I'll give this to you. Just to make a big point out of something. Alright, let's see. Do I even want to try to have this come out to an answer? Well, let's just see where this goes. What the hell? We might not be able to finish it up, but too bad. Can anybody identify which part of this will give people the most trouble? Where they're going to make a mistake?
X squared minus 1.
No. Well, hopefully.
Plus 4?
Yeah, why this dude? Because they think to themselves, it doesn't even have a bottom, so I don't even have to consider it. Yeah, it has a bottom. Everything has a bottom. What's on the bottom? It only has 1, so it needs every freaking thing, right? So if you have a whole number sitting there with all these fractions, you have to make it into a fraction so you don't forget it needs stuff too. Poor little dude. Dude. So what's the only thing I can factor on the bottom? Yeah. So what's he need? He needs an x minus 1, I like it. He needs everything. And let me see if you guys are cool with this. He needs both of these, so I might as well just write it like this. Because that's what the hell it is, right?
Okay.
Because what's the thing I would do after that is multiply shit back together. So I might as well just write it in multiplied together form. Forget about that, it doesn't matter. It's not the same way. Does he need anything?
Yes.
What's he need?
No.
No, good. I was curious. I want to see what he did. All right, let me stop there for a second and see. Quizzical faces. Is everybody cool with that? Is anybody worried about why I did this? He needs both of these, and both of these make this. So he needs that. So let's see, what do we get? This is nice. Yeah, x minus 1 plus 4x squared minus 4 equals 2x. And again, why? Because I multiply both sides by that. Die.
Murder, kill.
It's very cathartic to do that. And now you just attempt, now I warned you ahead of time, this might be one we can't quite do yet. Let's see what happens here. On this side, you get 4x squared. If I subtract 2x, why am I getting it equal to 0? And you're like, we don't know why you do shit, John.
So
Hey,
you
this
can
is going
find
to
out
work.
what the x's
Holy
are.
shit.
So you can just put the negative factor?
Yeah. Negative 1 minus 4 is negative 5. 4x squared is there. Why am I getting it equal to 0? Because of the stupid x squared, right? It's not stupid. I think this will work. How do I see if it's going to work? What do I have to check here? How?
Also part of 4x.
Yeah. If you factor negative 20 that had to be negative 1, they're staring me in the face. 4, negative 5. I should have just shut up and just took it. Yeah, I made that problem work. I got lucky. So to factor this, I rewrite the middle term. I'm going to put the minus 1 first. I'm not going to freak out about this guy because when it seems like there's nothing I can take out, I can take out 1.
Oh, can't you take out a negative and make that positive? Oh, no.
I could, but then it wouldn't be the same as him.
Yeah, okay. That's what I just looked at.
So what's the next step?
X plus 1
X plus 1,
and 4x plus 5
4x plus 5.
equals 0.
Good, so x is either negative 1 or add the 5 divided by 4. 5/4. Or if you need to, 7 equal to 0, add the 5 divided by 4.
Are you getting that?
Now watch, now this is cool. This problem, oh my god. I really wish I could take credit for making this. Are both of these okay?
No.
What about negative 1? If I try to plug it in, what's going to happen?
0.
Freaks him out, right? Gets a 0 on the bottom. Better throw him out. 5/4 doesn't make anybody freak out. You're fine. You're gonna make me freak out. I ain't gonna let you in.
Bad trip on mushrooms.
Or whatever it is. Could have been that. Alright. So, here. There's only 3 problems on this bad boy, so go ahead and try these.
So basically, everything we learned before this, you gotta do in these problems. So it's like if you don't, or if you're not sure about one step, you're gonna get lost because then you're gonna confuse yourself with another property of how you do it.
You have the exact format.
You just gotta like follow all the steps, just like how you did it. Each step.